In this problem, what we are asked to do is to take this system with a 450 Newton force, a 200 Newton force, and a 200 Newton meter moment and reduce it to a single force and couple that acts about point O. If you remember the steps you need to do to replace a system with an equivalent system, first step is sum your forces in the x direction. Second step, sum your forces in the y direction. This will get us our resultant force. From our resultant force, we can figure out our angle, and this is the force we replace it with. Then to figure out our moment, we want to figure out our resultant moment. In this case, this is going to be equal to the sum of our moments about point O, and we need to also add in any external moments that we have, and that's going to be that 200 Newton meter moment that we have. But if we take a look at the entire system, the sum of the moments about O, that would encompass this 200 Newton meter moment. So let's get started with this. First, let's sum our forces in the x direction. Okay, so now this 400 Newton force points backwards. If I say to the right is positive, this 400 Newton force points backwards, so it's minus, and it's going to be a sine of 30. So minus 450 sine of 30, and that's the only x force I have. So this is going to be equal to minus 225. Okay, now we can do the sum of the forces in the y direction. All right, again, if up is going to be positive, 450 points downward, so minus 450 times the cosine of 30, so that will give me my y component. And then I have this 200 Newton force that points upwards, so plus 200. And those are my only forces I have in the y direction. So this will equal minus 189.7. And that's newtons. So to get our resultant force, we have a resultant force right here. This is going to be equal to the square root of this minus 225 squared plus minus 189.7 squared. So if we square this term, we add in minus 225 squared, take the square root. We get this is equal to 294 newtons. Okay, and what is our angle? Well, first let's draw in my x. My x goes to the left, my y goes down. So my angle I'm finding is going to be this way. This is going to be what theta is. So theta will be the inverse tangent of y 189.7 over 225. And we get this is equal to 40.1 degrees. So this is our force. Our force has a magnitude at point O. If we're replacing this system with a force, magnitude is going to be 294 newtons, and it's going to be 40.1 degrees in this direction. So something like this. That's going to be our resultant force. I'm going to get rid of that right now so we don't confuse ourselves. But now we need to figure out the sum of our moments about point O. Now, this has some thickness. This thickness right here is 0.2 meters. And let's do the 450 Newton meter first. So if I break this up into x and y components, both of these components, none of them go through point O, so they're both going to have a moment about point O. Let's do this x component first. So with this x component, it's going to go head first when we rotate it around. So if I rotate in this direction, it's going to go head first, and it's going to be 450 times the sine of 30. This is the magnitude of its force. It's what we have right here. So 450 times the sine of 30 times this distance right here, which is 0.2. Okay, now let's do the y. The y is going to rotate tail first, so it's going to be minus 450 times the cosine of 30. And this distance is 1.5 meters. That perpendicular distance right here is 1.5. Okay, now we need to do this 200 Newton force. Well, the 200 Newton force is only in the vertical direction. The total distance is going to be 2 plus 1.5. So when we rotate it, it's positive. So plus 200 times 3.5. And then we have to add in this 200 Newton meter moment. And this 200 Newton meter moment is rotating in the clockwise direction. Counterclockwise is positive for us, so this is going to be minus 200. So now what we can do is we can just calculate this. And we get that this moment is going to be equal to minus 39.6 Newton meters. The minus sign really means that this is 39.6 Newton meters in the clockwise direction. So if we're redrawing this, and this is our system, and this is point O, our answer means we can replace this entire force system with, if this is my beam, I can replace this entire force system with one force that acts like this, and this angle right here is 40.1 degrees. This magnitude is, where is it? 294. And we have a moment that acts this way and is 39.6 Newton meters.